third part. Okay, linear programming, graphical method, part 3. In previous class we have studied about in first part linear programming and as an introduction, and in second part we have studied graphical methods for solving linear programming problem. Today also discuss about the graphical method, taking another types of problem. Okay, let us consider find out the maximum value of
ফারিহা ফারিহা আসতেছ আসতেছ আচ্ছা
হ্যালো, তোমরা কি শুনতে পাচ্ছ?
জি স্যার।
একটু নেটওয়ার্ক মনে হয় ডিস্টার্ব করছে। Okay, linear programming, this is the third part, linear graphical method. Understand this? তোমরা কি এটা বুঝছো? হ্যালো,
জি জি স্যার।
okay. Now for the first constraints, so another constraint x plus 2 twice y greater equal to 4. Last constraints, if x equals to 0 then y equals to what? 2, and y equals to, if y equals to 0 then x equals to 4. So plotting this 0 2 and 4 0, this is there are 2 points, 1 2, this is the 0 2. Okay, x equals to 0 and y equals to 2, and this is the x equals to 4, 1 2 3 4. Okay, y equals to 0, just joining these points. And this is the shaded region because for greater equal to, if greater equal to, then the shaded will be higher, opposite to origin. Here, this is the origin O. Okay, this is the opposite to origin. Understand? Now for the another constraints, thrice x plus y greater equal to 7, we got this point. Okay, 0 7 and 7 by 3 2. So 0 0 7, x equals to 0 and y equals to what? 7. 1 2 3 4 5 6 7, this is the 7. Okay, and 7 by 3 means what? Actually more than 2. Okay, greater than 2. So 1 2 greater than 2 here, 7 by 3. Okay, and y equal to 0, just joining these points. This is also greater equal to 0, greater equal to 7, this is why shaded will be higher, opposite to origin. Okay, this is the arrow sign, shaded region for greater equal to sign. Okay, if less equal to, then this here will be in this part shaded. Now for the another constraints, these last constraints, we get 0 comma 7 by 2. Okay, 0 comma 7 by 2 means what? More than 3. Okay, 3.5. So x equals to 0 and y equals to 3.5, this point. Again minus 7, minus 1 minus 2 minus 3 up to minus 7, this is the joining point. Okay, now this is the less equal to. Less equal to means what? Directed to origin. Okay, this is the shaded region. Understand everybody? This is the shaded region because of less than. If less than equal to, then the shaded will be in higher in the origin side. Okay, origin side. So combining these three inequality, first constraints this, and second one this. Okay, second one constant this, and third constant this. Okay, the first constant shaded region is this, and second constants, for the second constants, this is the shaded region, and for the third, this is the shaded region. So common shaded region, which one actually? Common shaded region, can you tell me? Actually this is the common points. Okay, these points, and these points, this is the common points. Okay, these three, this is the intersection point, this is the intersection point of what? This is the intersection point, and this is the intersection point, and this is the this part is the common region. common region বোঝা যাচ্ছে যে তিনটা পার্টে শেডেডটা এখানে কমন হয়ে গেছে, মানে তিনটার শেডটা এখানে আসছে। this is why this is the intersection point of what? First constant and last constants, and this is the intersection point of first constants and second constants. So solving this, solving 1 and 3, we get this point, and solving 1 and 2, we get this point. Okay, this point 2 1, this is the corner points. Okay, these three corner points, we have to maximize at these 3 points. Okay, now maximum z equals to 4x plus 2y points. How many points? Corner points 1 4 2 1 4 0 from graph 1 4 2 1 4 0. Okay, just putting this value x equals to 1, y equals to 4 in this objective function, we get 12. Another 1 2 1 4 into 2 2 1, we get 6, and 4 0 this. Actually 16 is the maximum. Okay, so this is the, hence the optimal solution will be what? X equals to 4, y equals to what? 0, and maximum z will be obtained at 16, and the value maximum z will be what? 16, and at point what? 4 0. Okay, solve graphically the following linear programming problem to minimize the cost. This, and this is the constraints, 3 constraints are given. This is the non-negativity restriction. So combinedly this is called linear programming problem. We have minimized z equals to this, subject to the constant this. Now conversion, first part is conversion, converting the above inequality to the equality equations. Okay, this is the first equation, second equation, third equation, and x equals to 0, y equal to 0. Okay, now drawing the graph for the first inequality, first equation. Okay, putting y equals to 0, we get x equals to what? 10 by 5 equals to 2. Then putting x equals to 0, y equals to what will be? 10. So this is the A point, and this is the B point. Now we can take this in graph 5x plus y. This is the first graph 0 2, this is the 2 0, and this is the 0 10. Sorry, 0 10, right? This is the first equation. Okay, first inequality, and since this is y greater or equal to, so region, shaded region, what will be? Opposite to the origin. Okay, now for the second inequality, second equation, putting y equals to 0, x equals to what? 6, and putting x equals to 0, we get y equals to 6. So there are another points C and D. 0 6, 0 6 means this, and 6 0 what? 6 0 this. 0 6 what will be? This, just joining this point, joining CD. Okay, and shaded region where will be? Opposite to the origin. So for the third constants, x plus 4y greater or equal to 7, and third equation, we get what? If y equals to 0, x equals to what will be? 12, and if x equals to 0, y equals to what will be? 12 by 4, that means 3. Okay, so this is the point EF. Every maths you will solve like this in this process. Okay, this is E point, and this is the F point. E point what will be? 12 comma 0, 12 comma 0 what? This is the 12. Okay, 12 0, this is the E point. Now another point, x equal to 0, y equal to 3, then this one, this is the point. Okay, this is the straight line, third inequality. So feasible region higher will be opposite to the origin. Okay, this is the, so this is the actually feasible region, and shaded for the 3 constants. This is the common region for the three constants. So there are intersection points Z and H. Okay, this is the intersection point, and this intersection point of 1 and 2 inequality. Okay, 1 and 2 equation, and this is the intersection point of what, 2 and 4, 2 and 3, 2 and 3 constants. So solving 2 and 3 we get Z point, and solving 1 and 2 we get H point. Understand everybody? And this is the how many corner points? This corner point, this corner, this corner, and this corner point. 10, 0, 10. So there are 4 corner points, and for this corner points, 4 corner points, E, G, H, B. These 4 corner points. So these 4 corner points, maximum Z will be what? Just putting x equal to 12, y equal to 0 in this, we get 36. So minimum what? Minimum 13, and minimum 13 occurs at what? 1, 5. So x equals to 1, y equals to 5 is the optimal solution of the given linear programming problem. So minimum value of Z what will be? 13. Understand? Solve the graphically the following linear programming problem. Maximize. This is the maximize Z equals to 5x plus 3y subject to the constant. These two constants only. So maximum objective function these two constants. Now converting the above inequality to the equality equation, we get this. Okay, just taking equal sign. Now drawing the for the first constants and first equation, if y equals to 0, x equal to what will be? 300, and if x equals to 0, then y equals to also 300. So point A will be 300 0, and point B will be this. Joining these 2 points, we get the first line. So for the second inequality and second equation, another point C and D. Okay, joining CD, we get the line. Again, this is also non-negativity restrictions for this is the x-axis and x-axis, y-axis. So now we take a constant value, say 300. 300 is the constant value. Now this is the first inequality. First inequality where 300 0 and 0 300. Okay, 300 0, 300 0, 300 0 higher this is the first inequality. Okay, first equation, first constants, and another constants, which one? Another constants 180 0, C point what? C, this is the C point, 0 300. Okay, this is the C point, and D point what? 300 0. Okay, so C will be actually 180 0, and D will be 0 360. So plotting this graph, C equals to what? 180 0, and this is the 360 0 360. Just joining, we get this inequality. Okay, now if we take the constant value, say 300. Okay, 300 means actually this is the 300 values, and this is the what? 300 values. If we join this, we get this line. 20 times in the of 5 and 3, putting z equals to 300, objective function becomes what? 5x plus 3y equals to what? 300. So dividing by what? 5x plus 3y equal to 300. So we can draw this. For x equals to 0, y equals to what will be? 300 by 3. That means we get another value of, for this equality line. If we put y equals to 0, x equals to what will be? 300 by 5. So the parallel line to 5, this is the parallel line, objective functions line, passes through the farthest point 60 and 240, because this sum will be 300 from the origin. 60, x equals to what? 60, x equals to 60, y equals to what will be? 240, this point. from the origin. So x equals to 60 and y equals to 240 will give the maximum value of z. The maximum value of z is given by 5 into 60, 360. This is the actually isocost method for finding the inequality. After plotting the first constants and second constants, we get these corner points. Okay, and these corner points, and this is the corner points, 3 corner points. Now the maximum value what here? 300. Maximum value of y what? 300. And there are the maximum value what? Only 180. So if we consider total objective function what? Total objective function 5x plus z equals to what was 5x plus 3y. Okay, so total objective function will be 300 because the highest value is here 300. So 5x plus 3y equals to 300, and this 300 will give the parallel. This is the parallel line of 5. This is the equation number 5, and farthest through the value 60 and 240. This is the value 60, and this is the value 240. Very near to 0300, and this is near to 180 point. This is the actually isocost method for finding maximum or minimum z. Okay, similarly example 5, solve the graphically following minimization problem. Okay, in isocost method, subject to these two constants only. We have the minimize z objective function 5x plus 4y. This is the constants. Okay, two constants. Now converting the above inequality to equality equations, we get this. Okay, now drawing the first graphs for the first constants and first equation, we get if y equals to 0, then x equals to what will be 88 divided by 80, that means 1.1. And if x equals to 0, then we get y equals to what will be 0.88. Now we can join these 2 points, a 1.10 and b will be 0.88. So for the second constants and second equation, we get the points c and d. Okay, for the similar process. Now if we plot this graph, first graph will be a point and b point. Okay, a point will be what, and this is the b point, and this is the a point. Okay, so just joining this 0.088 and 11.0, this is the a point. Okay, just joining this, we get joining this is the first inequality. Now second one what will be c point and d point. Okay, c point what will be 0.90 what, just before 1. Okay, just this whole one, just about near 1. Okay, and d point what will be 1.2, more than 1. Here 1, more than 1. This is the b point. Just joining this, we get 40x plus 30y equal to 36. This is the, and this is the c point, is the intersection point. Intersection point what? C. And this is the greater equal to. This is why the shaded region will be higher, opposite to the origin. Okay, for greater equal to sign, opposite to the origin. There are 3 points, A, C, and B. A, C, and B are the corner points. Understand, everybody? Understand? And this is the corner points. So highest value actually, joining this C and D, we get the graph this. So putting x equals to y equal to 0 in the required equation, this for, so the actually plotting, for plotting we are using this. Now isocost method, and now put if we take a constant 20, on putting z equals to 20, this is the objective function 5x plus z equals to what, 5x plus 4y equals to 20. And c point what, intersection point 0.6 and 0.4. How many how it comes, just solving these two, understand, solving x for y. If we multiply this with 2, then if we multiply with 4, this multiplying 2 by equation, multiplying equation 1 by 2 and multiplying equation 2 by 4, then after subtracting we get the value of y, and putting the value of y in any equation of this, we get the value of x. Then 0.6 x equals to and y equals to what will be 0.4. So for the isocost method, isocost method, actually for maximum we have to minimize the cost actually. This is the minimization problem, and this is the line, objective function line. Okay, this is the objective function line. If we take a constant 20, z equals to what will be 20. Now we draw the graph of line 5x plus 4y, then 0 and parallel to the, we can draw, if x equals to 0, y equals to what will be 20 by 4. Okay, and if y equals to 0, then x equals to what will be only 4. 20 by 5 what? 4. So the point will be like this. X equals to what? This is the parallel line, 5x 4y line after plotting for objective function only. Now the parallel line to 5, this 5 passes through the nearest point 0.6 and 0.4. Actually this is passes through the nearest point. This is the corner point. Okay, 0.6 and 0.4. So this point is the very nearest. This is why it will be the feasible solution for this isocast method. We'll give the minimization value of z. The minimum value of z is given by z equals to what will be, just putting this point 0.6 and 0.4 in the place of x and y respectively. We get 4.6. 4.6 is the actually minimum z values. This will be homework. Solve the graphical each of the following linear programming LPP problem 1 to 5, just for 2 constants. Okay, 1 to 5 will be homework for you. Understand everybody?
Yes, sir.
And this example will be homework for you. Just example 6, isocost method, maximize or minimize. There are two parts. First of all, we have to maximize. The maximum value will be the result, and another part is minimize. Minimum value will be the result. Less equal to and greater equal to sign. Less equal to will give which part? According according to origin. Okay, directed to origin, and greater equal to will be opposite to origin, shaded region. Remember it. So graph will be like this. Okay, this is the first inequality, first equation. Less equal to, this is y, directed to origin, and another will be what? C D. Okay, this is the second inequality, and third inequality E F. Okay, first quadrant will give the feasible region. Remember it, first quadrant. So this is there is a corner point D E. This is the intersection point of 1 and 3, and D is the intersection point of 2 and 3. Okay, 2 and 3. So solving E and D, you get the maximum or minimum values of Z.